Hello and welcome to Maths Learning. In this video, we will look at the trapezium rule used for estimating the area under a graph. Suppose we had a graph like this, and suppose we wanted to find the area under the graph between the points x equals 2 and x equals 10. Usually we would use calculus to give an accurate answer, but sometimes with difficult equations it's more difficult or impossible to work out the integration, so it may be better to use the trapezium rule instead to give an estimate. With such a graph, we could get an estimate of the area by calculating the area of the trapezium formed as shown. This would be an overestimation since we have included more of the area than what we are trying to evaluate. A better estimation would be if we split the distance between x equals 2 and x equals 10 into 2, creating two equal strips, and work out the area of the two trapeziums formed as shown and add them together. As you can see, this gives a better estimation since we have followed the slope of the graph a bit better. Obviously, if we were to divide the distance between x equals 2 and x equals 10 into more equal strips, we would get a progressively better estimation of the area. So this is how the trapezium rule works. We split the area into equal width trapeziums and add them together. Instead of working out each area of each trapezium individually, we use a formula called the trapezium rule, which has combined the formula of each of these trapeziums into one formula. H is the length of the strip, which may be given in the question, or you'll have to work this out depending on how many strips are required. Y0 is the length of the first side of the first trapezium, and Yn is the length of the last side of the last trapezium. Then all of the other lengths of the sides of the trapeziums go here. If you look carefully, apart from the first and last length, all of the other lengths are used twice, since they form a side of two adjacent trapeziums. So it forms one of the sides of this trapezium and one of the sides of this trapezium, and that is why we double these lengths in the formula. So once you worked out how many strips there should be and the length of those strips, you can work out the x value of the start and ending of those strips. Once you have the x values, you can use the equation of the line to work out the y values. You may want to set this out in a table. Then it's just a matter of putting the h and the y values into the trapezium rule formula. You may also be asked to compare the estimation to the true value worked out by calculus, or explain whether the estimation is an overestimation or underestimation, or whether it's not possible to tell because in such cases the tops of the trapezium fall above and below the slope of the graph. It does not matter how the graph looks, we will work out the area in the same way using the trapezium rule. In this case, the trapeziums are below the slope of the graph, and therefore it is an underestimation. Now let's work through an example. This graph is y equals x squared, and we want to find out an estimation of the area below the graph between the points x equals 2 and x equals 5 using three strips. We start by drawing a table. N refers to the side of the strip starting with 0. So here we have 0, 1, 2 and 3. The x value starts at 2 and ends at 5. Splitting this distance into three strips gives an equal length of 1, so we can fill in the rest of the x values. The thing to note that if there are a certain number of strips, then add 1 to get the total number of sides. So here we want 3 strips, so there are 4 values of n starting at 0. The corresponding y values are worked out by putting the x values into the equation of the graph, which in this case is x squared. If we put these values into the formula using a calculator, making sure we are careful with the brackets, then the answer will be 39.5. If we were to work at the area by integration, then to integrate x squared, we add 1 to the index, making it x cubed, and we divide it by the raised index, making it a third x cubed. We do this for the limits of 2 and 5. So we put 2 into the expression and we subtract it from what we get when we put 5 into the expression. This gives us 39. So as you can see, the estimation is greater than what we worked out by integration, confirming that the estimation was an overestimation. Hopefully you found this video helpful, and if you did, give it a thumbs up and don't forget to share, comment and subscribe, and I will see you in the next video.